welcome to this new activity about an application to ergonomics of quadratic functions. So here we have a marketing research department of a company that manufactures and sells memory chips for microcomputers, establishes the following price-demand function. So we have here the price-demand function given by P of x equals 75 minus 3x. It's available for x between 1 and 20, where P of x is the wholesale price in dollars at which x million chips can be sold. So the P here represents the price, the x represents the quantity, but be careful, the quantity is in million chips, okay? So the first question is express the revenue function R of x as a function of x. So first of all, we're gonna write our revenue function. Remember that the revenue function is given by the quantity, in our case it's x, times the price. And the price here is P of x, a function of x. We multiply x by 75 minus 3x. And we obtain our revenue function, R of x, in a quadratic form, minus 3x squared plus 75x. Okay? Now, second question. It says find the value of x that will produce the maximum revenue. First of all, let's make some commands here. In this quadratic function, which is the revenue function, we have a coefficient of the quadratic term, a equals -3. So -3 is negative. It means that the vertex represents a maximum. So we are sure that we have a maximum in our function R of x, okay? Now, how to determine this maximum? You just simply try to find the vertex, okay? And to find the vertex, we have to compute h, which is negative b over 2a. So the b here is 75, so negative 75 over 2 times a. A is -3, so over -6, which is equal to 75 over 6, and it's 12.5. So this represents the x-coordinate of the vertex. But in our case, the x-coordinate represents the quantity. So here, the quantity that maximizes the revenue is x equals 12.5 million chips. Okay? The second part of the question says, what is the maximum revenue? And here we have to find the output of this quantity which maximizes the revenue. So either you compute directly k, or you compute R of x with x equals 12.5. So let's compute R of 12.5 to find this maximum revenue. And if you plug in the 12.5 inside the revenue function expression, you will find that it's 468.75, and the units here is not dollars but million dollars, since the quantity is in million chips and the price is in dollars, so $1 million. Okay? So this is the maximum revenue we can get. Now the third question is, what is the wholesale price per chip that produces the maximum revenue? The question is very simple. You have the quantity which maximizes the revenue. You have the relationship between the price and the quantity. So just substitute x by 12.5 in the price-demand equation. So we're going to do this. Third question. We're going to compute P of 12.5. So it's equal to 75 minus 3 times 12.5, so we have 37.5, which is the half of 75, so the wholesale price will be 37.5, and the units is dollars. Okay, so this is the price you have to charge to get the maximum revenue. Thank you for your attention, and see you later in other videos.